The battles of World War II brought new strategies to the fore. Chief among them was the ability to use technology to wreak destruction from afar.
The combatant nations were by and large using conventional iron bombs that had been used 20 years before during the First World War. Yet, by the end of the Second World War, the atomic bomb had been developed and dropped on Japan.
Throughout the war, as new technology, new methods are coming, the way that you go about bombing is evolving. But the central thesis that I can destroy the enemy's means of production through bombing, that strategic bombing is a war-winning resource, that does not change.
From the quirky to the revolutionary, from the successes and failures. Each was designed in secret to serve a particular purpose or solve a new problem. And if they succeeded, they were revealed for the first time as a blazing ball of fire. In the early hours of the 17th of May 1943, a group of modified Lancaster bombers were about to take flight. The final preparations for Operation Chastise were underway. The target was dam infrastructure in the industrial heartland of Germany. The success or failure of this mission would be decided by a new type of bomb. Codenamed Upkeep.
Operation Chastise, better known as the Dam Busters Raid, was a different kind of bombing raid for Bomber Command. So where they'd been carrying out this kind of mass area bombing, talking about big areas, this, in contrast, was kind of more of a surgical strike. So the superiors at Bomber Command have been looking for industrial targets, something that's going to harm the German war effort. And they identify 3 dams in the Ruhr Valley as good bombing targets. And they are the Murner Dam, the Eder, and the Sorpe.
Bombing these dams along the Ruhr River would cause major flooding downstream and disrupt the power supply to Germany's industrial heartland, at least temporarily. But the dams weren't an easy target.
Dam structures are very difficult to actually destroy because of the shape with a very wide base and very narrow crest. And very difficult to hit effectively from the air with airdrop weapons.
So a conventional bomb wouldn't work. And then in 1942, Barnes-Wallis starts work on the bouncing bomb.
British engineer Barnes-Wallis had been working on ways to bomb enemy infrastructure when his attention turned to dams. His solution was a bomb that could skip across the surface of the water before detonating against the dam wall.
Precise delivery of the dam-busting weapon was crucial to the destruction of the dam. It needed to be spun from the cradle underneath the Lancaster bomber that was carrying it at 500 revolutions per minute.
The bomb would then be dropped from a height of approximately 18 meters at a distance between 122 to 152 meters. If these precise conditions were met, the bomb would bounce in a curving arc trajectory, similar to a tennis or golf ball.
This enabled the bomb to skip across the dam lake, contact with the dam wall, slide down the wall, and when it reached a preset depth, a hydrostatic pistol inside the bomb would detonate, setting off the explosive charge, which would crack the dam wall, and then the back pressure of millions of gallons of water would push the concrete structure and allow the water to force open the wall.
It was an unusual plan, and if it paid off, a costly one for German production.
The Dam Busters raid was top secret from the very start. That included the development of the weapon, the specialist training of the crews, and the code names that were used for the bomb and the operation.
On the night of the 16th of May 1943, the heavily modified Lancasters of Squadron 10 took off in 3 separate formations. Each bomber carried a single bouncing bomb. By the time they had reached their targets, their numbers were diminished. Of the bombs that were successfully dropped, not all made it across the water to the dams. But enough did. The price of destroying the Möhne and Eder dams for the Allies was the loss of 8 bombers and 56 aircrew. For Germany, it was an economic disaster. The dam's failure destroyed 4 power stations, 12 war production factories, and damaged another 100. Repairing the dams diverted 7,000 workers who would have otherwise been building the Atlantic Wall. The total cost to Germany is estimated to be over 6.9 billion euros by today's value. Between 1,200 and 1,600 civilians, Soviet prisoners of war and slave laborers were killed in the ensuing deluge. Unconventional weapon design, like the bouncing bomb, led engineers and scientists to experiment with many delivery methods and techniques. Some were effective, some were visionary, others were just outlandish. The US Office of Scientific Research and Development awarded a contract to General Mills for a missile homing device. But this device was not a machine. Instead, it drew on one of nature's most talented homing creatures. The US military was looking for ways to guide missiles more accurately. Project Pigeon was psychology professor B.F. Skinner's answer. He was already using pigeons in his research, training them to press a lever to receive food. He thought it should also be possible to train them to guide a missile. The design that worked best had 3 pigeons together in the missile's nose cone, sitting in 3 separate compartments. A lens on the cone projected an image onto a plate in each compartment, which the pigeons were trained to peck. When they pecked at one of 4 directions, a corresponding air valve beneath the plate would open, venting air out of the missile to keep it on target. Unfortunately for the pilots of these missiles, they were never expected to return home. The missiles being used for the project were top secret, so even Skinner had to make educated guesses at how they would work. While tests with the Pigeons were successful, they never made it into combat, and the project was often not taken seriously, a fact that Skinner himself would lament. While attitudes weren't always positive, the project continued in different forms into the 1950s. Only halted when electronic guidance systems were reliable enough to become the prevailing technology. Project Pigeon may have seemed unorthodox, but it wasn't the only time the US tested animals in their bomb technology. In the first 11 days of December 1941, the US had suffered the shock of Japan's attack on Pearl Harbor and declarations of war with Japan, Germany, and Italy. They now needed to gain the upper hand over their enemies and do it fast. In the midst of this need came a bold and unusual idea, a way to weaponize the humble bat. It was simple enough. Strap incendiary devices to bats and drop them over Japan, where they would fly into cities and cause large-scale fires. President Roosevelt thought the idea was at least worth exploring, and with that, Project X-Ray was born. Thousands of Mexican free-tailed bats were captured and taken to military facilities for testing. Each bat was fitted with a tiny celluloid capsule filled with napalm that was attached to a time delay fuse and placed into a metal canister while unconscious. The plan called for the canisters to be airdropped at night over Japanese cities. And once they were 300 meters above the ground over their target, they would open and release the armed bat. The bats, now awake, would fly off looking for somewhere to roost. When safely tucked away in the eaves of Japan's many wooden buildings, the timed fuse would ignite the napalm, setting fire to the structure. Fires that could quickly spread into massive conflagrations. The chief chemist of Project X-Ray estimated that in this way, as many as 4,748 individual fires could be ignited per bomb load, compared to at most 400 fires per bomb load of conventional bombs. Initial tests by the US Marine Corps were mixed at best. Some bats were able to start fires, but the failures ranged from early deployment of the incendiaries to bats that didn't wake up, became confused, or collided with each other. The bats also couldn't identify test buildings, which led to rogue fires on the base. Ultimately, by the time testing was taking place in 1943, the focus of US resources was shifting to the atomic bomb. So, Project X-Ray became yet another weapons project destined to remain an oddity of war history. But not all unusual bombs devised during the war ended in failure. Some delivered exactly what they were designed for. On the 18th of April 1942, 16 B-25 Mitchell bombers took off from the USS Hornet aircraft carrier. Their target was Tokyo. The objective was to show that Japan was not invulnerable to attack. The air raid left Japanese military planners with a problem: how to bridge the distance to attack the American mainland. They would turn to an unusual solution: the Fugo balloon bomb. The Fugo was designed to carry a payload of 5 bombs. 4 thermite incendiary bombs and either a single 12 or 15 kilogram Type 92 high explosive anti-personnel bomb. Attached to the 10-meter diameter balloon envelope filled with hydrogen gas, the Fugo was designed to take advantage of wind patterns to travel long distances and drop a bomb on an enemy target.
I think one of the most notable aspects of the design was how it took advantage of the jet stream, which is something that many scientists really didn't understand well at the time. The Japanese figured out exactly where and when to release the bombs for maximum efficiency to carry them to the North American continent.
In the winter of 1943-44, Japanese scientists studied the winter jet stream. Flowing from west to east, the jet streams are incredibly powerful wind patterns high up in the atmosphere. They are strongest during the winter months and can reach speeds of up to 400 kilometers per hour. The Japanese scientists found that a balloon launched from Japan could travel the jet stream and reach America around 30 to 60 hours later. But to travel the jet stream, the balloon would need to be light. The Japanese Army and Navy devised 2 separate designs, one made of a Japanese paper called washi, the other using rubberized silk. Both were filled with hydrogen, which was part of its delivery system and the means of destroying the balloon once it reached its target.
There was such a shortage of manpower. They had to mobilize high school girls to put the balloon together. So they had the high school girls free from class. They would go and the Army would get them organized and they would actually put together and laminate the layers of the balloon. And when the balloon was finished, it was a kind of a pretty white color, kind of satisfying, symmetrical shape. Deadly device on the bottom of it, all built by high school girls.
The long distance between Japan and the USA also meant the balloon would need to travel during the day and night, where temperature changes would affect its altitude. So engineers designed a system to control altitude in flight.
They had to maintain the altitude of the balloon, because if the balloon flew too high, the balloon would burst. If it flew too low, it would crash in the ocean. So the genius device they came up with was, first of all, they put an automatic release valve in the top of the balloon. So as the balloon rose, the hydrogen would naturally expand as the air around it got thinner. And if the balloon got too big, then the automatic release valve vented hydrogen, which would bring the balloon back down to below pressure height, altitude. But if it got too low towards the ocean, they had an aneroid barometer attached to sandbags at the base of the balloon. So the barometer could sense when it was getting too low, it would automatically release sand and allow the balloon to rise.
By the time the balloon reached the Pacific coast of America, the sandbag ballast would be exhausted, at which point the same barometric pressure switch that had been dropping the ballast would instead begin dropping the Fugo's payload. It was hoped that the balloon bombs would not only target cities and farms, but be able to start fires in the vast forests of the west coast of the US. On November 3rd, 1944, Japan was celebrating the former Emperor Meiji's birthday. It was on this day that the first balloons were launched.
Over 9,000 of these bombs were released during the war, and some 300 made it to the North American continent, including some that made it as far as the state of Michigan. In one very unfortunate case, a family happened across one of the downed balloons, and when one of the children went to check it out, unfortunately the bomb exploded and killed the family, all except the father, who was still parking the car, and he survived.
The reaction to the U.S. and the Fugo balloons was very muted, largely because the U.S. government censored all news about the Fugo balloons in the beginning. So the American public was not aware of the balloons. Later on, the U.S. government had a change of heart and let the media begin to report on some of these because they were concerned about Americans accidentally coming across one of these things. They wanted to know what it was.
The Fugo never lived up to its promise in wartime, but it was technically the world's first intercontinental bomb. Japan wasn't the only nation to invest in some peculiar bomb designs. The Allies had their share of strange and secret projects, one of which would start in secret, but its failure would be public. For years, Germany had been preparing for the inevitable Allied attempt to retake occupied Europe. They constructed a series of fortifications, bunkers, pillboxes, and trench works stretching along over 4,800 kilometres of coastline. In response, the British began developing a unique anti-fortification bomb.
The Panjandrum. What a weird and wacky idea that was. It was like a large cotton reel. It was like a pair of wheels with rockets all the way around and a bomb in the middle. So you light the rockets, goes up the beak, bang, there you go.
The Panjandrum consisted of a set of 2 wheels, each 3 meters across, with tread around 1/3 of a meter thick. The wheels were joined together with a hollow tube filled with explosives. Around 70 rockets were fitted to the outside of the wheel, which would propel the Panjandrum towards German fortifications, detonating on impact. This unusual creation was designed under a veil of secrecy.
Now, the secrecy that surrounded the development of the Panjandrum was extraordinary. Nobody in Leytonstone mentioned a word to their family. People since have said, I worked on it and nobody ever knew a single thing about it. And as long as they were constructing it, there was total secrecy. But then, of course, they had to test it.
Strangely, the testing site chosen for this secret weapon was a not-so-secret beach at a popular English tourist town.
So to test it, you need a beach, like the beach of northern France. So the government decided we would go to Westward Ho in the West Country. Like all of those other West Country towns, the seaside towns are tourist centres. So thousands and thousands of tourists saw the tests.
With this first test, the weapon was no longer a secret, nor was its spectacular failure as tourists watched it stagger across the beach and fall over. Subsequent tests of the Panjandrum revealed one design flaw after another. Proving unsuccessful, the project was terminated. But not all British bombs designed during the war were style over substance. One would take a simple design approach that maximised the scale of its destruction. Between October 1942 and October 1943, Allied forces made over 200 daylight bombing raids on German U-boat pens. But these were heavily fortified concrete structures, and the bombing campaign led to the death of 1,200 Allied aircrew and the loss of 135 of their bombers. Any real damage needed a new kind of weapon. Earthquake bombs.
The RAF's arsenal of conventional high explosive bombs was perfect for destroying the industrial areas of the Ruhr and also civilian population centres. But when it came to damaging concrete structures and deep-seated installations such as U-boat pens, they barely scratched the surface.
As early as 1940, Barnes Wallis was designing a bomb capable of dealing damage without a direct hit.
Barnes Wallis had identified a need for a specialist type of bomb that could actually achieve destruction of these troublesome targets. And the result was the 12,000-pound Tallboy and its big brother, the 22,000-pound Grand Slam earthquake bombs.
Each massive bomb would be dropped from high altitude, would penetrate deep into the ground, and then explode. This would cause a strong but localized earthquake capable of destabilizing nearby structures.
Some of the technological innovations used in Grand Slam enabled it to achieve its earthquake bomb effect. Streamlined steel casing made of molybdenum high-tensile steel filled with 9,135 pounds of Torpex high explosive was delivered from 17,000 feet. The fins of the bomb were canted 5 degrees, which enabled the weapon to actually spin on its way down to the earth. And in so doing, these fins helped stabilize its free fall down onto the ground. Once it reached ground point, it penetrated the surface of the ground down to about 90 feet, and the earthquake effect of the explosive detonating would shake down structures like viaducts and bridges, which hitherto were unassailable by conventional bombs.
While the bomb had to be carefully designed to meet exact specifications, so too did its means of transportation. The Grand Slam was so massive that it had to be carried by modified Lancaster bombers.
It had a specially modified bomb bay and structure whereby the nose and mid-upper turrets were removed to save weight. The bomb doors were removed and special bomb release mechanisms and calipers for actually hold the bomb in the belly of the aircraft were installed.
The first Grand Slam was used against a viaduct near Bielefeld on March the 13th. From then until April 1945, 9 further targets were attacked. Most were strategic infrastructure, including railway viaducts and bridges, gun batteries, and submarine pens.
The Grand Slam bomb was significant in disrupting the German war effort, although only 41 of the bombs was actually dropped by the end of the war. It was very successful in destroying targets like the viaducts in northern Germany. But had the war continued, there's no doubt that the use of these bombs would have been very effective in utterly disrupting the transport infrastructure of Germany and other strategic targets.
Ultimately, the Grand Slam emerged too late in the war to demonstrate its full potential. Another latecomer in the war would tell a different story. Its technology was so revolutionary, its impact would be felt long after the war ended. On the 13th of June 1944, Germany launched a new type of bomb across the English Channel at Britain. A new terror campaign had begun, delivered by a new secret weapon and designed to strike fear into the heart of the British people. The weapon was the infamous V1 flying bomb. And it would soon be followed by its successor, the V2 rocket. The German V weapons, first the V1 and then the V2, were conceived for retaliation against the Allies for their destructive bombing campaigns on German cities.
The V1 flying bomb and the V2 rocket were Germany's two first vengeance weapons, or Verwaltungswaffen, which were developed in conditions of utmost secrecy at the secret research establishment at Peenemünde on the North German coast.
And really, they were kind of the first weapons of mass destruction, designed to scare, damage morale, and to cause as much physical destruction as possible.
The first was the V1, the world's first cruise missile. Utilizing a pulse jet engine, this pilotless device was launched from an inclined rail.
The V1 was both clever and simple. It's both advanced and elementary. 8 meters long with a wingspan of 5 meters. The simplest rocket motor you can imagine. It became well known throughout the later years of World War II because of its effect on morale. Londoners would hear it growling up in the air, and suddenly it would go silent.
An odometer tracked the distance the V1 traveled. At a preset distance, it would sever power to the engine.
It was now falling. You didn't know where it was going to fall.
This rudimentary guidance system made the V1 horribly inaccurate, and was only really effective against large areas. Compounding this issue, the V-1's top speed was not fast enough to outrun Allied fighters, and its altitude put it in range of anti-aircraft batteries. But Germany had another revolutionary secret weapon in the works. The first successful V-2 rocket launch took place on the 8th of September 1944 from the Hague-Wassenaar area in Nazi-occupied Netherlands. Their targets were the recently liberated Paris and long-standing enemy, London. By early 1945, the Germans were firing around 60 V-2 rockets a week at Britain.
The V-2 rocket was by far the most sinister of the German vengeance weapons. It was a world's first ballistic missile that was powered by a liquid fuel rocket motor and could fly at speeds of 5 times the speed of sound to deliver its destruction onto London.
At launch, the V-2 would fire its rockets for 65 seconds, taking the rocket to the edge of the Earth's atmosphere. Once here, the rocket engines would cut out and the V-2 would begin to fall back to Earth.
That's why it was a ballistic missile. Didn't need a rocket motor to take it to its target. It would blast off, and then it would cruise up into the edge of space and back down again.
It was at this point that the rocket's advanced gyroscopic guidance system would guide the rocket onto its target. As the missile fell, it could reach speeds of 5,400 kilometers per hour, much faster than any conventional anti-aircraft defenses had any hope of intercepting, allowing the V-2 to accurately deliver 726 kilograms of explosives up to 320 kilometers away. In this way, V-2s launched from Northern Europe would reach London in approximately 5 minutes. This deadly combination of altitude, speed, and its accuracy made it a far more deadly weapon than the V-1, as no conventional anti-aircraft defenses could identify or intercept the missiles before they struck. By the end of the war, the Germans had fired nearly 10,000 V-1s and more than 3,000 V-2s at their enemies, leaving thousands dead, injured, or homeless. The V-weapons were powerful and sophisticated, but even they would soon be eclipsed by another secret weapon, one designed for ultimate devastation. In 1939, famed physicist Albert Einstein feared that Nazi scientists were inching closer to a weapon that could harness the immense power of nuclear fission. He wrote to President Roosevelt to warn of this impending threat, initiating a chain of events that led to the most destructive bomb ever created, given the deceptively innocent codenames Fat Man and Little Boy. The Manhattan Project was established in 1942 and led by theoretical physicist J. Robert Oppenheimer. The scale of the Manhattan Project was unprecedented. Spread out over numerous American states, at its peak, over 130,000 people were employed on the project, from laborers to Nobel Prize winners.
And they also had an advantage that probably the Soviet Union and others did not have later on, and that is they had a blank check. The Manhattan Project, at the end of the day, was $2.2 billion in 1940s dollars, which today is about $25 billion. So they had all the money and not all the time in the world, because they were on the clock here. They were trying to beat the Nazis to it.
This massive project was shrouded in secrecy. Not only did they want to keep their enemies in the dark, but their ally Joseph Stalin too. Only a handful of top scientists knew the full extent of what was being developed. Everyone else was focused on their piece of the vast and complex puzzle.
Now, the security around the base is very, very tight. What most people did not realize until after the war was that this is the golden age of Soviet espionage. The Soviets have spies everywhere.
On the 12th of April 1945, Vice President Harry S. Truman was sworn in as President of the United States, following the sudden death of President Franklin Roosevelt. As President, Truman was finally made aware of this top-secret bomb project. 3 months later, on July the 16th, 1945, the first successful test of the atomic bomb, nicknamed Gadget, took place on US soil at the Alamogordo bombing range in New Mexico.
With nuclear weapons research, the emphasis was on damage. So much so that before the Americans detonated the first atomic device in the New Mexico desert in 1945, there was some speculation that it might even ignite the atmosphere.
A day later, Truman informed his allies Churchill and Stalin of this destructive new weapon at the Potsdam Conference.
He walks up to Stalin at the Potsdam Conference and says, "We have a new weapon we're going to use against the Japanese." And Stalin's just smoking his pipe, and he looks at Truman and he says, "I hope you use it well." What Truman didn't realize is that Stalin had complete knowledge of what was going on at Los Alamos and the Manhattan Project. He probably knew more about the atomic bomb than Harry Truman did.
In less than a month, the world would know of this new power. US planners wanted the perfect target to showcase the destructiveness of their new superweapon. Being compact and relatively untouched by the devastating US air raids other Japanese cities had suffered, Hiroshima was deemed the ideal testing subject. On the 6th of August 1945, the US B-29 bomber Enola Gay was loaded with an atomic bomb nicknamed Little Boy and took off from Tinian in the Mariana Islands. Little Boy was filled with uranium, separated into two parts. Known as a gun-type bomb, one was the projectile, the other the target. When the two met, the fission reaction was initiated. Three days later, a second bomb known as Fat Man was dropped on Nagasaki. Fat Man was an implosion-type bomb. A plutonium core was surrounded by explosives which, when detonated, compressed the plutonium until it triggered a runaway chain reaction. Where Little Boy exploded with a force equal to 15,000 tons of TNT, Fat Man exploded with a force equal to around 21,000 tons. Both wrought devastation on their targets. Although estimates vary, the likely death toll across both cities from the blasts and radiation is approximately 200,000. On the 14th of August 1945, Japan formally surrendered. The debate about the use of the bomb and its effect continues to this day.
I tend to support the argument that they should have dropped the atomic bomb. And the reason for that is that Operation Downfall, which was the invasion of Japan, was locked and ready to go. And it would have been horrendous in terms of the cost in American lives, but also the cost in Japanese lives.
The atomic bomb encapsulates the two phases of weapons development during the war. At once, an unfathomable destructive force and an incredible technological advancement.
It was all about technology. Technology is what? It's about applied science. So you had all these brilliant scientists involved in the Manhattan Project to develop a nuclear weapon. And alongside the people who were experts on quantum physics and theoretical physics, you had chemists and engineers and people who had to make a bomb and then deliver it. So you had this very close-up marriage between science and technology in the last part of the Second World War.
While some of the more unusual bombs designed during World War II failed, there were also many successes. The bomb was, and remains, a weapon that can tip the balance in favor of those who wield its power. Launched or dropped from afar, if designed well, it can deal out great destruction on an enemy and turn the tide of war. It was this potential that led many to strive for something newer, bigger, more powerful and unexpected than what had been done before. A goal that led to some of the most destructive weapons in history. Power that was built to destroy and which would change the political landscape of the 20th century, but which would also drive great advancements in technology and propel us into the stars.